As we mentioned, new tools have enabled new forms. Sigrid, can you please explain what we mean by new tools?
So there are three categories of tools that have recently been added to the engineer's toolbox. Tools to find shapes, tools to analyze shapes, and tools to make shapes. Since the late 1960s, computer power has tremendously grown, and the development of computer methods has given us many new ways to find new forms for vaults, to study and detail these new forms, and to build them in an economic manner. First, we will have a look at new digital tools that allow designers to generate a whole variety of structurally sound vaults.
You might remember how Heinz Isler used a physical hanging cloth dipped in plaster to generate the ideal shape for a vault. Building such a physical model is time-consuming, does not provide all the information the engineer needs, and is difficult to share with clients and architects.
We can now generate many ideal vault shapes on the computer without having to build physical models due to the development of form finding and shape optimization tools. The form you see here being generated is based on the same process Heinz Isler used, a hanging cloth model. Only the form here is generated on a computer and does not use a plaster-dipped cloth.
Once the shape of the vault has been found using form finding or optimization tools, the engineer needs to verify and detail it so that it is safe, strong, and stable enough. Engineers no longer use slide rules, but use computer simulation methods such as the finite element method to do this.
For example, you see the model of a finite element calculation of a double shell divided into small elements. The computer model shows us how the stresses change as we apply loading to this very flexible system. This computer method allows us to analyze vault shapes that are difficult to calculate using the slide rule or the calculator.
Now that we have a structurally sound vault, this form needs to be built in an economic way.
The computer can also convert the shape of the vault into a fabrication pattern. This pattern can be expressed into a series of machine-controlled commands and feed it into a computer numerically controlled or CNC machine. An example of such a machine is the laser cutter. The laser cutter shown here uses laser technology to cut flat materials such as wood or steel. This tool leaves a high-quality surface finish. The new generation of CNC fabrication tools allows engineers to economically construct new shell forms.
In addition to new tools, the last 20 years has seen new materials being used for vaulted forms. Some of the materials are as old as the earth, literally, meaning earthen shells. And some of the materials are new engineered materials, such as glass fiber reinforced plastic. Let's go over some of these materials and some examples.
Earth is one of the oldest construction materials. There is a renewed interest in constructing earthen shells because of their low carbon impact. You see here a Catalan vault built in South Africa. This vault was recently made with earthen bricks. Another old construction material with low carbon footprint is wood. Wood comes from trees and trees are linear. Engineers have been building vaults made out of a grid of wooden lats. Before, with reinforced concrete and Catalan vaulting, the vault surfaces were continuous. This vault now has holes. This is a new kind of structure, which we call a grid shell.
So far, we've talked about old construction materials being used in vaults. But what about newly engineered materials? Sigrid, why don't you tell us a little bit about that?
Yeah, for example, plastic reinforced with glass fiber has been used in this grid shell, designed to cover a congregation space of a cathedral in France. Or in this example, this grid shell is actually made out of paper. Of course, this is not a common structure, but one made for a fair. However, we do see that shells and grid shells are being built today in a variety of materials besides reinforced concrete.
Iron and glass were used in the 19th century for greenhouses, but recently we are seeing more of this type of steel glass construction for large spanning roofs. Next, we will examine and compare two meshed steel and glass structures, the Berlin Central Station and the Dutch Maritime Museum.